All right, round two. Another practice problem, number two. All right, so we'll read through it and I'll go kind of through the same steps that we did before. So it says a pressurized balloon at 105.3 kilopascals is in a room that was at 28 degrees Celsius with a volume of 250 milliliters. If we decrease the volume of the balloon to 100 milliliters, what would the temperature of the balloon be? All right, so let's go back and let's write everything in. So we end up with a pressure. So we'll put pressure at 105.3 kilopascals. Okay, is in a room that was at 28 degrees. So we have a temperature, and it says it's at 28 degrees Celsius with a volume. All right, so we get a volume, and that is at 250 milliliters. If we decrease the volume, so we're talking about decreases. So I understand that that is going to be volume 1. So this is going to be a volume 2 to 100 milliliters. What would the temperature be? So we have a temperature 2. So I'm going to go back and put that 1. And I'm going to put my question mark right there. I don't know what it is. Of the temperature be. So we look at all these, right? And it only gave us one pressure. So technically, we could just discount that and we could go back to the correct law and say, all right, which of the laws should it be? But the easier way to do it would probably just to be say, hey, pressure 2. If it didn't give me another one, we can just assume that's the same thing, right? So we can assume that if they didn't tell us anything, that the 105.3 kilopascals is just going to be a constant. They didn't say it, but they also didn't say that it changed or give us another one, right? So we'll go with that. So knowing we have two pressures, two temperatures, two volumes, right? We're going to use the combined gas law. And so when I go the combined gas law, generally we write it as, I'm going to change colors, generally we write it as P1 V1 over T1 is equal to P2 V2 over T2. But in this problem, more often than I would care, most of you algebraically could solve this problem. But some of you would get the inverse of what you want, because you'd bring the P and the V over to this side and you'd leave it and you'd call it T2, but really it'd be 1 over T2 because you haven't flipped the problem. So what I would do, anytime you're trying to solve for a t, because it's in the denominator, I would flip these ratios right away, right? So I would say T1 is equal to P1 V1 and T2 over P2 V2, right? Then you're going to end up with what you want. I know it doesn't seem like a big change, but it is. So what we're going to do is we're going to solve for this. So I'm going to write in my equation solving for T2, because that's what I want, is equal to T1, P1, V1 on the bottom, and P2 and V2 are going to cross multiply at the top, right? So I'm going to have P2 and V2, right? So I love this. This is what I want to see from you guys. Do all the hard work before, then you can just plug and chug, right? You can just toss in the numbers where they go, and you'll be good. So that's what this last step is. I can just go back and I can look. Oh, but I have a problem, right? Kilopascals, milliliters, right? Those are fine. This is not fine, right? That has to be in Kelvin, right? So to get to Kelvin, we have to add 273 to it, right? If we don't, we're not going to get the right ratios, which seems kind of odd. But we also, in different problems, we are also going to end up with incorrect answers. Either way, we end up with incorrect answers, but we could set up some problems where we end up with negative volumes and stuff like that, and that just doesn't work. So what we have here is we have a Kelvin that we need. So that's what I'm going to write right here. I have 301 K, there's no degrees for Kelvin, times my pressure 2. So again, this is why we're being very organized. 105.3 kilopascals times my V2, which is right there, 100 milliliters. My P1's on the bottom, so that's 105.3 kilopascals times my 250 milliliters. All right. So it looks like a little bit added work because of this, but not only does the unit cancel, but the number cancels, making it easier. Our milliliters cancel, right? And so we're left with the unit of Kelvin, which is good because we're solving for T. And so now in the end, we just got to multiply what's left. So we have 301 Kelvin times 100 divided by 250. And so we end up with 120, right, 0.4 Kelvin. All right, so in this case, we are super cold. That wouldn't be a good thing. We wouldn't be living in that atmosphere. All right, I'll see you on the next one. Enjoy.